On to Chapter 1, Section 4, Exponential and Scientific Notation. Here we'll go over the product rule and quotient rule, zero exponents, negative integers as exponents, simplifying something like this, raising a power to a power, raising a product or a quotient to a power. We'll do scientific notation and significant digits and rounding. Okay, this is taking a little bigger chunk. Okay, now when we are multiplying and our exponents have the same base, here the base is A, here the base is A, and we're multiplying. Well, what do we do? Well, interestingly, all we have to do is add the exponents. So if this were a 3, and this would be a 4, this would then be a to the 7th power. Okay? So we keep the base, we just add the exponents. Whenever we're dealing with a variable with an exponent, and we're asked to multiply it, we just add the exponents. But again, the bases have to be the same. So let's do this one. Z to the 8th times Z to the 3rd. Well, the bases are the same, so we're just going to get Z to the 11th here. Now for this one, we have some numbers to deal with, so we're going to multiply a negative 2 times 7 and get negative 14. Then x to the 5th, y to the 18th. And we'll see that. There's our first one. And there's our second one. So negative 14, x to the 5th, y to the 18th. We're just adding the exponents. We multiply the actual numbers, though. Now, how about if we're going to divide examples, terms that have exponents? Well, the general rule as you look at it, whichever number is smaller, we're going to subtract. Remember, if we multiply, we add. If we're going to divide, we're going to subtract. So I have a little rule that I sometimes describe as this. When an exponent comes from the bottom here and crosses this division bar, the sign of this exponent changes and becomes the opposite sign. And that's what we have here. Okay? Now we usually want to have positive exponents. So there is a case where if n were larger, we would bring the m down, change it to a negative m, and subtract it from the n. And remember, there's a 1 still up in the denominator there. But we'll get to some of that in a little while. So here, we're going to take the 7. As it crosses the division bar, it becomes a negative 7. So this will give us m to the 8th. Now here we're going to do some canceling. 9 goes into there once. 9 goes into there twice. We're going to bring the 2 up. It's going to become a negative 2. So this is going to become a 4. Bring the 5 up, becomes a negative 5. So this becomes a positive 3. Let's check it. All right, m to the 8th. And again, 2x to the 4th, y to the 3rd. Very good. And notice they're showing the steps. Normally we do this part mentally. Another major item here is the zero exponent. Now we had said always if a number in the form of a variable is like this, does this have an exponent? And we said yes. There's a 1 there that we don't write. But how about if there is a 0 in the exponent spot? Well, here's the general definition. Anything to the 0 power, as long as it's not a 0 as the base, is 1. And the proof of that, let me show you the proof of that here, because this might be helpful. So if we had a to the 3rd divided by a to the 3rd, the rule is we'd bring that up, subtract 3 there. This would then become a to the 0 power. We're just subtracting that and we're getting 0. But notice what we had here originally. We had a to the 3rd divided by a to the 3rd. What is anything divided by itself equal to? Well, it's equal to 1. That's why a to the 0 is equal to 1. So we could take this away for a moment here and say anything divided by itself, that's a 1, and that's a 1. 1 divided by 1 is 1. But that's the proof of a to the 0 is 1. Now, 0 raised to the 0 power, remember that's undefined. We don't have a definition for that. Okay, some of these might be a little tricky, so watch them carefully. Think about it, what will this be? Anything to the 0 power we said was 1. This one's a little tricky because what is the base of that 0 exponent? Well, it's only the letter y. So this part is 1. Negative 2 times 1, this is going to be a negative 2. So sometimes they'll try to catch you a little bit. Now, if it's in a parenthesis like this, that implies everything in that parenthesis is to the 0 power. This is 1. And by the way, in this case, we were supposed to put 5 in all these, but didn't make any difference at all. Okay, so if you put a 5 here, 5 to the 0 power, that's 1. Negative 2 times 5 to the 0 power, 5 to the 0 power is 1, so that's negative 2. And this would be negative 2 times 5, negative 10 to the 0 power, still 1. Okay. You'll be having some practice, and hopefully you're going to do well on your Quizme's. All right, we're now going to look at what we call negative exponents. So we had said, again, every number is over 1. And there's a 1 up there as well. We just don't write them. But what we're going to do is take this negative exponent, cross the division bar, and what happens to the sign of the exponent? It changes. So up in the numerator, it's negative, but down in the denominator, because it crossed the division bar, it's now positive. So this and this are equivalent. Taking this and raising it to the numerator would make it a negative exponent. Okay? And by the way, we often think of these as being reciprocals of each other. A little tricky. Okay, here they want you to express using positive exponents only and simplify if possible. So as we look at number or letter A here, see if I can get a pen in action. There we go. This is going to become 1 in the numerator, and then 12, bringing the negative 2 across the division bar, and it becomes that. And 12 squared now we know is 144. Now notice here the 2 will stay up in the numerator. X to the negative 6 will go down as x to the 6th, and y is already positive, so that stays up. And here we're going to just bring the negative exponent across the division bar, and that becomes m to the 4th. And again, it's over 1, but we don't write the 1 there. Okay. Now, when we have something like this, notice all we're going to do is bring the numerator to the denominator, and the exponent crossing that division bar becomes positive. As it does with the negative m crossing the division bar, it becomes positive. So let's do this and try to keep everything positive. So our 5 is going to come down as 5 to the 1st, which will just make this a 5. Our w is going to go up. That becomes w to the 4th. Our x will come down, x to the 6th. And then our y to the 3rd stays on top. Everything now has positive exponents. Okay? This goes down, that other one goes up. Okay, the product and quotient rules apply for all integer exponents. Simplify this. Well, here, they're not saying they want it in positive exponents, but just in case, we'll do it both ways. You'll have to see what they're asking for in the practice and in MATLAB. So this is going to be x to the negative 11th by adding a 2 and a negative 13. And if we wanted it in positive form, it would be 1 over x to the 11th. Now here, if we wanted it in positive form, we're bringing the negative 4 up. It becomes a positive 4. So this eventually becomes m to the 2nd. And again, over 1, but we don't write that. Okay, they showed you the negative exponent part and the positive exponent part of letter A. And then this is letter B. Now here they're changing things a little bit. And they're saying for any real number A and its integers, M and N, what do we do here? Well, this is called raising a power to a power. So this would be something inside the parenthesis. I accidentally went forward on there. There we go. And when you have something inside a parenthesis and then a exponent outside, to get a result, you multiply now the exponents. And that's what they're showing you here. Raising a power to a power. Let's look at some examples. Now to show you how letter A works, what this is our base, and we're going to use that base 4 times. So this is the shorthand way of showing what I have written here. But now as you do this, this is going to be 8, and we add our exponents to the negative 8. Well, this is the shorthand way. How do we get this to this from this? And the answer is we just multiply when we are raising a power to a power. And if we wanted that to become positive, we just put it in the denominator. Now for this one, it would be 8 times I would write 5 to the third. So there'd be 5 to the third 8 times. So I'm just going to shorten it by saying 5 to the 24th power. And this one, I'm going to go 5 times 16. And notice it's a negative. And a negative times a negative makes it a positive. That same rule applies. So this is going to be 80. Negative 5 times negative 16 is a positive 80. Now let's check them out. So there's with the negative exponent, there's the positive exponent. There we're just multiplying and we get that. And here again we're multiplying negative times negative and we get that. Now when we're dealing with quotients, that's sort of like a fraction that we're raising it to a power. Something similar exists, and notice there is an exponent of 1 there and 1 there, and we just distribute in a sense. So this becomes a to the nth, b to the nth. So let's check this one out. So here we're going to have remember there's a 1 there and a 1 there. We're going to multiply. So this becomes 3 to the 4th, y to the 4th. And you may or may not know that 3 to the 4th is 81, y to the 4th. And here this is going to be 5 to the 3rd, because there's a 1 there. This becomes x to the negative 9, y to the positive 15. And if they didn't want negative exponents, this is going to be 125 over, bring the x to the negative 9 down. In the numerator, it's negative, but in the denominator, it's positive. Y to the 15th. Okay. All right, now again, raising a quotient to a power. There's a 1 there and a 1 there. And multiplying, because you're raising it to a power, it becomes this. So here, this one will be 9 to the second power is 81. Y to the 8th. Remember, there's a 1 there, so it becomes 9 to the second power, 81, and this. Now this is going to be x to the negative 5, y to the 15th, and this is going to be z to the 10th, because it's negative times negative. And here, to put it as positive, y to the 14th over x to the 5th, z to the 10th. We'll check our work here. Yep, and this one. Now keep in mind, you can always rewind the tape, go back as needed, look at something, and we do have the additional exercises all worked out for you as well. And there's 2 forms of those lessons. So this is a summary of what we've just done. If you want to pause the tape and copy this into your notes, might be a good exercise for you. We're now going on to scientific notation. This is going to be a little longer tape, but let's see if I can summarize it. Scientific notation is when we take big numbers and small numbers and put them in a form in which we use powers of 10. We take the big and small numbers and put them between the number 1 and 10, and then depending how many places we had to move the decimal, that will determine our power of 10. So let's check it out. So here, we're going to take this big number, the decimals here. I'm going to move the decimal to make it a number between 1 and 10. There's 3 places, 4, 5, 6, 7, 8. So my decimal goes there. These are the significant digits. So it's going to be my decimal times, and then how many places did I move it over? In this case, to the left. That's a positive 8 exponent. So decimal or standard notation, scientific notation. Okay, let's do this one. I'm going to move it 1, 2, 3, 4, 5, 6, 7 places now, and it becomes 6.3. And I moved it 7 places to the right. So this is times 10 to the negative 7. Negative exponents indicate small numbers. Positive exponents, large numbers. Okay, here's another one. Moving it over 1 place, and that's 0.9 times 10 to the negative 1. And again, the decimal place is here. I'm going to move it 2 places over, 1.9 times 10 to the second. Perfect. And you'll be trying some out shortly. Now, when you have to convert to decimal notation from scientific notation, you can do something like this. Write the number 3.842. Now, how many places are you going to move the decimal? Well, right over here, you look at the exponent, it says 6. So we have 3 places, so now we have to add 3 more zeros. So that when we move it, it's going to be 1, 2, 3, 4, 5, 6. Comes out very nicely. Now here we have 5.3. How many places will we move the decimal? 7. But this time it's going to be to the left. So there's 1. So I have to add 6 zeros. 1, 2, 3, 4, 5, 6. And then that's where my decimal is going to go. And then I add another 0 to fix the place of the decimal. So I need to move the decimal 7 places from where it is. So that's 1, and then 6 more, period, to show you the decimal place, and then another 0 to fix it. Okay? And now to write in scientific notation, here the decimal place is right there. 1, 2, 3, 4, 9.4 times 10 to the 4th power. You moved it 4 decimal places. Here we're going to move it 2 decimal places. And this will be 4.23 times 10 to the negative 2 places. And that's how it works. And again, through practice, and, if you feel confident, you can go directly to the quiz bees. Okay, now another thing they do in our math class is they talk about significant digits and rounding. Now, when you put a number between 1 and 10, notice we didn't keep zeros. We just kept the 1s, the 2s, the 3s, etc. We call those significant digits. But if one measurement has 2 significant digits and another has 4 significant digits, and you're kind of multiplying those in a sense, how many significant digits should you have in your answer? And the key is it's the least number. So if you had 2 in one number you started with, in your answer you're only going to have 2. Because otherwise, keeping more than that doesn't lend itself to accuracy. It's just tedious. Because remember, when we're multiplying decimals, they keep adding more decimal places. All right, let's see what they're talking about here. Yes. And we round off. So I'm going to do this one for you. We're going to multiply this by this, and then this by this. And they do it for us here anyway, so let's just do that. Now, when they multiply these two, they get this. Now, how many significant digits? Well, here we had 2, here we had 3, and here there's 4. So we're going to round off to how many? 2. So we go to the third place here in a sense, and that's a 0. So we're going to drop this, and that should be our answer, 8.5. Excellent. The same thing applies when we do division. We're going to do this division and this division. Remember, when that 8 comes up as a negative 8. And this is going to give us a little fraction here. So we end up with something like that, and we get this. Now, how many significant digits? Well, we had 2. Oh, here's only 1. Well, in a sense, it's 0.0. So let's see what they're going to do. Well, they kept actually. What they did is, this is not in scientific notation because it's not a number 1 to 10. So when they moved it over one place, this part of it had one more negative exponent, in a sense, that we have to add there, and it gave us this. Now, I would think that where this answer is okay, that they should have rounded that off to 7.8. But this is what they're doing, and you're going to have to follow what they want you to do in the exercises. They will say how to do that. And we're not going to be using a graphing calculator, so that winds up this rather long session here.